everyone. Welcome to the live chat. It is hot. Very, very hot. And it's also July 20th, 2022. We are in the dog days of summer. And that means that, once again, we are going to be testing our electrical grid. And we're going to talk about climate change. And we're going to talk about summer storms and tropical weather and non-tropical weather. But mostly we're going to talk about the fact that it is hot, very hot throughout the northern mid-Atlantic. As we look at temperatures for this evening, let me just go to the map here and take a look at the temperatures. It is 8 o'clock at night, and it is 90 degrees in Monmouth County, 91 degrees in Trenton, 92 degrees in Philadelphia. And by the way, with the urban heat island effect, those temperatures are going to take a while to fall. So I would not be surprised in Philadelphia you end up with a low of around 80, 79, somewhere with that. And the problem with that, and this is a perfect example of urban heat island effect, is that because you're retaining that heat, you're starting at a higher base. So heat waves become worse and worse because your low temperature ends up higher each progressive day. So you start off at, let's say, 75, you warm up to 95, you drop down to 80, then you do the same rebound again, but now instead you get up to 99, or in case of Newark and Teterboro, around 100 degrees. In fact, yeah, Newark did hit 100 degrees today. So the perfect century point. So it's, am I still live on Facebook? I mean on Facebook. YouTube? Looks like I might have frozen here. Can everyone hear me? Everything just froze. Okay. Okay, everyone. Let's see here. We're waiting to see whether or not YouTube is catching up or not. Babe, let me know when it's good on your end. It's good now? It looks like we're good. I think we're good. Testing 1, 2, 3. It's not on my end, I know that. How about let me know if you guys can hear me and see me. Okay, all right. So we got live over here. All right, it's back up again. All right. Well, gotta love technology. Okay, and you know that's another thing too. Okay, what we just experienced right now: increased solar activity, stress on the grid, stress on the internet because more people are at home, staying indoors, playing video games, whatever, streaming. So that stresses everything. It's amazing how the weather compounds each other. And we were talking about the urban heat island effect before we froze. I'm not sure how that impacted how much you guys heard. But basically the idea is this. Philadelphia, you just fell to 89 degrees at 8 o'clock at night, right? This morning we were in the 70s. Now our low temperature is going to be around 80 for tomorrow morning. And now when we rebound again in the afternoon, you're more likely to hit towards 100. Newark is more likely to be around 80 degrees for a low. And so the next day, tomorrow afternoon, there's a chance where you could jump up to... Well, the DJ thing came on. I don't know, things are weird tonight. You just got hit with a horn?
Yeah, when you started the chat, you had that tester
yeah.
before? That thing hit me when you started the chat.
Are you? Wow, what a weird night. All right, well, the heat's driving everyone nuts. I don't know. Okay, so where were we? Okay, so yeah, we have the urban heat island effect. We have people with short fuses. In fact, let me just tell you a story here. Let me go back here. Okay, so of course, everyone, when we get a heat wave, we start talking about climate change, okay? And rightfully so in some respects, especially with what's going on in Europe. What's going on in Europe is insane. You know, you're talking about temperatures around 100 degrees in England, and that's really hard to pull off. It is a historic event. But there are some people who want to say you should use climate change as a reasoning for every heat wave. And I don't think that's accurate. And the reason why is because it becomes dangerous trying to connect climate change to every weather event. Some weather events happen because they're within the climatological norms. So, for example, this heat wave that we're having right now has a very loose connection to anything with climate change. There's nothing out of the ordinary for what we're experiencing right now. Is it hot? Yes. Is it uncomfortable? Absolutely. Is the humidity a real pain in the neck? No question about it. But is this something that we don't experience in July and in early August? Absolutely. You know, some years we look out and we don't get one. Other years, boom, we get smacked with a good one. And in fact, I remember a couple of years ago, we had a heat wave where our average temperature was around 103, 104, and we had dew points in the upper 60s to lower 70s, heat indexes around 120. That could be an example of a climate change influence type heat wave, okay? But this one isn't. And the reason why it's important to make that distinction is that, and again, some people disagree with me on this. Dr. Mann definitely would. In fact, I got blocked by Currently yesterday and Joe Bastardi at the same time because of what I said defeats both extremes. In that, the reason why you have to recognize that this heat wave is not climate-induced or climate-enhanced is because then you can make a baseline comparison between a heat wave period that is in a normal climate setting in a temperate zone region, which is the United States. Compare that to England, which, you know, yes, you have to take into account of urban heat island effect, but guess what? They've been building and they've been having concrete for a long time. All right. Remember, Europe's buildings and growth goes back a lot farther than the United States. Okay. Now, granted, technology is different, but still, you had castles, you had this, so you had gradual buildup. Okay. But you can't just blame all that on urban heat island effect because of the nature of the 850 millibar temperatures and the 500 millibar heights. Combine that with the moisture content, that is how you pick up the precipitant water values. That is how you pick up how this is a unique feature in Europe. Conversely, in New York, it's not. Now, people who are very much giving you it's a climate crisis or whatever, or the world's ending, all this stuff, they don't want to hear that there's some areas where this is normal, right? Because they want everyone to think everything's going to hell in a handbasket. But you need to have a baseline to make a comparison, to explain to people who may not understand the differences in what is a natural event and what isn't a natural event, okay? And it's important to have those baselines because then you can understand the physics involved. You see, then you can educate the public the physics involved and why one event is different and unique and should really catch our attention, and one not so much. Okay, so like when they make comments like, oh, you know, thousands of people are under 90-degree weather. I'm like, well, yeah. Have you been to the Southeast? Many locations, that's their average high temperature. So, yeah, there's nothing unusual about that. All right, and that's why it's important to make these distinctions, because if you want to educate the public, not scare them, educate the public, then you have to explain what is baseline, what is normal, what factors should you expect, and what's really unique. What's really, hey, this is a warning sign. This is a canary in the coal mine, so to speak, okay? So if you understand those differences, then you can make a more accurate explanation on how we're seeing the climate change. Okay? So, and of course, this year we really have been lucking out in terms of not having the worst heat waves, so that's certainly some good news. The plains have been brutal. Believe me, I've been there. It's not fun. So, let me jump back to the screen here. Oh yeah, by the way, I have a little bit different setup, so I'm trying to test it out tonight. So again, back to our temperatures here. This is going to be problematic for tomorrow morning. It's going to be humid. It's going to be ugly. Don't be surprised if we get some fog out of this, especially in your valleys. So definitely be prepared for that. Is there going to be any break? Well, let me pull up 500 millibars. We'll take a look at the European, the GFS, and make some comparisons. Now, what we need, and let me go to where we are right now. Our Western Atlantic Ridge is building. This week trough here keeps us open up to the threat of an isolated thunderstorm or two, but for the most part, you get a southwesterly flow, and you can see that very nicely here with our winds. There's our Western Atlantic Ridge. There's our heat ridge in the plains and the Rockies. The weakness is caught in between. We've been forecasting this for weeks, heck, months. Well, here it is live. If you had any type of tropical system over here, it would just head right up the coast. But since we don't, and I'll talk about why we don't in a moment, basically we keep this weakness here. So basically any cold front that tries to come through is basically going to stall somewhere out here. So that means the Western Atlantic Ridge right here is just pumping up tropical air, and you could basically track where this air mass is coming from, basically from the tropical Atlantic, from the Bahamas, right up into our neck of the woods. Okay? And the reason why we're not seeing any strong cold fronts is because our polar jet stream, although it's amplified, which is normal for La Nina, okay? During La Nina, you typically have a more amplified polar jet stream and a very weak subtropical jet stream. So here's your polar jet stream amplified, but because it's not able to dig as far south, because climatologically speaking, in July and August is when your polar jet stream is the weakest. So it isn't able to dig as far south. You typically don't get deep troughs. So your cold fronts are more likely to be focused in the St. Lawrence River Valley, and that's where our upper level features are. That's where our strongest lifting is. So when these cold fronts approach, yeah, they move through, but they don't have much impact. So as a result, we keep on pumping in tropical air after tropical air, and we can see that very nicely here on the water vapor satellite picture. There's our upper level lows marching across. Not much different from what we were dealing with a couple of weeks ago. Back in June, the only difference between this pattern and the one that we have now is that these upper level lows were digging just a little bit further south. This upper level low was down here in Michigan rather than up here in Ontario. That's the only difference. If this was a little bit further south, we get a stronger cold front, we get knocked down to the 70s, no big deal. But because we shifted the polar jet stream a little bit further north, as we should for this time of year, it's more difficult to get those polar air masses into our region, and it's easier to bring back the tropical air masses coming right up from the Bahamas, the Gulf of Mexico, and the tropical Atlantic. Now, is there any indication at all for any type of tropical development? Well, this is the Sahara dust. Okay, when you see a lot of red here, and I'm colorblind, so when I see a lot of red, that means we are going to be quiet for a bit. This is a lot of dry, dusty air. Okay, and the best way to think of it is if you have ever been to a baseball game and they throw down the diamond dust to dry out the infield, right? That's essentially diamond dust for the tropical Atlantic. It dries out the mid and lower and mid levels of the atmosphere. So you can't really get any type of tropical system to develop. And so that's essentially what you end up with. A intertropical convergence zone that's suppressed and weakened, and any one of your short waves that come off the African coast basically collapses as it moves into this dusty air. Now, eventually, we're going to see a change. Let's see, I think it's this one right here. Here we are. The forecast from the GFS and the European guidance is to start to seeing more activity in zones 1, 2, and 3. Why is that important? Well, that starts to really enhance the short waves that come off the African coast, and then those will start to bring more moisture back into the tropical Atlantic and cut off the Sahara dust plume. So the idea here is that for the end of July and for the start of August, we should see more activity. And we are starting to see indications of that in some of the model guidance. Let's see here. So we're starting to see this signature more and more. Now, this doesn't mean it's a guarantee. Doesn't mean we know what type of hurricanes or tropical storms we could develop. But what we do know is that we're seeing more support as we move further and closer towards August for more support of tropical development. And then once we start getting tropical development here and we get any type of storm in this neck of the woods, that is when we start watching out for this signal showing up and funneling tropical moisture or storms right up into the southeast and towards our neck of the woods. So that's certainly something that we're going to be keeping an eye on and watching for. A lot of clues in that respect. In terms of any break for our heat wave, well, we're going to see some breaks. And the signal I'm seeing here is that I'm seeing an agreement from a lot of model guidance of this trough around Ontario and Quebec digging just a little bit more, just slightly bit more. That would indicate to me the increased potential for showers and thunderstorms. I'm not ready to go with sustained rainfall. I know the model guidance keeps on showing that. I think that's an error. I think that's convective feedback. Basically, it keeps on showing, let's see here, this type of signal with what looks like widespread rainfall. I think what you're really seeing here, and a good way to read this, is that it's trying to pick up these thunderstorm lines. You can see kind of like these somewhat bullseyes here. And so by doing so, it has a hard time dealing with that latent heat release. And so what it does is it creates this bleeding all over the region. So in reality, what you have is a line here, maybe a line down here, and nothing really happening over New Jersey. So it looks like there's a potential for some cold fronts with some strong storms, but I don't see any widespread rainfall. Let's see here. One other thing. What was the other point I want to make? Oh, yeah. In terms of the pattern evolution and the MJO. Okay, right. Our La Nina still is present. It's starting to weaken just a little bit. Notice our SOI values are falling off. Look at the trends here. And we're seeing more and more daily positive phases and negative phases. So what that means is that overall, we're going to see a gradual weakening of La Nina, but still have La Nina conditions through at least October. And the CPC's MJO forecast, let's bring this up here. Basically what we have here is a neutral phase. So the dominant tropical forcing here is La Nina. The MJO is very weak. Yeah, you might see an indication of maybe it's 7-1 here, but the dominant influence is La Nina. So those are my thoughts right now as far as the forecast. I figure I'll take some of your questions and we'll drop by into YouTube, see what we got there. Looks like we've been active, certainly. So I'll refresh that and make sure I get the latest on that. So first we'll start off with the premium chat room. And let's see here. Already losing power in Middletown. Half the town is out. That doesn't surprise me. I'll tell you, one of the things that we're going to get, because We're looking to do a house, as you all know. What? Generator, yes. Definitely. In freehold, it sneezes and we lose power. So we're definitely looking to get a generator, and the grid's going to be pressed. It's going to be pushed, so it doesn't surprise me one bit. No ice cream truck in our neighborhood. Yeah, and you know what? We haven't heard of the ice cream truck around here either. It's like 40 degrees and we'll get the ice cream truck to come by here. 99 degrees? Nothing. I'm surprised. Maybe it melted. I don't know. Okay, now Card brings up a couple points about England, so let's check them out. Let's see here. England has to do more with building equals the urban heat-on effect, and they are in the big ridge of amplified La Nina polar jet. Partially correct. Okay, yes, you definitely have to include urban heat island effect. But they've been dealing with urban heat island effect for, 90, 100 years. Remember, their infrastructure, their buildings have been around a lot longer than us. So that factor in terms of looking at their climate data is not as significant as saying comparing New York City to 1800s to now. Obviously, there's a huge growth there. In England, and especially in Great Britain and locations like that, the urban island effect was actually kick-started much earlier. It's pretty interesting. Definitely check out some of the research work at Cambridge. They've been going back. They've actually found examples of urban island effect going back to the 1750s. Granted, nowhere near what we have now, but still some indication of that. In terms of the ridge point, yes, it's definitely amplified ridge, but the 500 millibar axis ridge, the heights, are actually near record breaking or at record breaking. But combine that with your precipitable water values going up to 2.5. Now, what does that mean? Now, remember, it's an island. It's surrounded by water. So normally, yeah, you'd have plenty of moisture in the atmosphere. Duh, right? But you don't typically see 2.5, combine that with an 850 millibar temperatures around 24 to 25 degrees Celsius, mix all that down, those are all record-breaking, unusual events. So if you said to me, hey, Stephen, the 850 millibar temperatures around 18 degrees, it's over a ridge axis, you throw an urban island effect, there's your high temperature. Then I would say, yeah, that's pretty much within the ballpark of what you would expect in terms of the mid-level dynamics. So I would agree with you, not a climate event. This is because of the nature of the air mass and the way that it basically feeds back on itself, and the ridge axis involved, the enhancement of the ridge axis involved. And the only way the ridge axis has been able to get enhanced as it has is because of the enhancement of the precipitable water values. Forget the temperatures, guys. I know the TV and all these guys, they like talking about temperatures, and they always bring up the record temperatures. I don't care about temperatures. Temperatures can be augmented by airports, by airplanes, cars, the location of buildings. What doesn't, because of the way that we calculate it, is precipitable water values. The more moisture in the atmosphere, the thicker the 500 millibar heights are, the more you can get that feedback process, and the more that the influence of CO2 enhancing that greenhouse effect becomes more understandable. Then you can create a direct mathematical connection to the event. And that's the key. When you take physical met in college, you will have equations that deal with the hydrostatic equation, okay? And you'll be able to make these connections mathematically and see how they're connected. It takes about an hour to work out the equation. So if you're bored, you got nothing to do, you don't feel like watching TV, it's a fun equation to do. So that's why. And that's why I like using it, because I can mathematically point to what's unusual and what isn't. 2011 had a bigger, longer heat wave, was also La Nina, very interesting winter that year. I recall that we have a couple La Nina years with heat waves like this that had some rather interesting winters that followed. Okay. I'm assuming you mean here. Those winters came with a weakening La Nina going into the winter, which could be similar to this. So when you exit La Nina, you go back to more of a neutral influence, tropical influence. That means your subtropical jet stream is a little bit stronger, but not overwhelming. Your polar jet stream is still strong, but not overwhelming. If you could get the high latitude blocking, yeah, you could end up with an interesting winter. That's probably how you ended up with those scenarios. Politicians prefer to scare people. We saw that during the pandemic. Oh, okay, here we go. It's all about declaring emergencies that serve a pretext to grab power. Okay. How do I put this? I haven't met a politician that hasn't wanted to grab power. I don't care who you vote for. Okay? I can't answer for that. I can just tell you the science. With that being said, I think if we have gone nuclear over 20, 30 years ago, we would be nowhere near the issues that we have now. I'll just put it that way. Looks like we are 90s again next week, but only low 90s to mid to upper 90s. Yeah, I'm not convinced of those 90s just yet. Because of the strength of the jet streams. Let's see here. Of these troughs on the European and the GFS, and also on the ensemble guidance. I think with this type of break and with the ridge positioned out here, I think we get more of a break and more in the mid to upper 80s. We'll see. What caught my eye is the fact that the ridge that builds on here on all the guidance basically starts to collapse over the southeast. If it was just the European doing that, I would say it's an error. But the European, the GFS, the European ensembles, the GFS ensembles all do this. So what it tells me, if it verifies, is that it's trying to pick up a transport of more polar air into the region. But it's having a difficult time handling the physics involved with doing that. And so I think we're seeing some model error. So I kind of want to flesh this out over the next 7 to 10 days and see how that works out. But I think that's what we're seeing. Do you expect this heat wave this week into next week to be the longest, hottest, or do you expect just a quick break to the upper 80s for a day or two and then back into the upper 90s to near 100 in an extended period? I would say this, okay. Now through early August, of course right around my birthday, is going to be the hottest we're going to be this summer. All the conditions are there. I do like the idea of a break within that period. And then we rebound into the mid-90s again, probably the first week of August, and then we fall back. The last couple of days of July, in fact, July 31st is a very important day for me. You might ask why. Well, I hate summer. I hate being hot. I hate having to run this air conditioner. So ever since I've been 14, since going back to when I was 14, I've always been very, very celebratory of July 31st because starting July 31st, our average temperature begins to fall and we start to head towards fall. So right now we're in the peak of summer. I do think we're going to remain in this hot and humid weather pattern, more humid than hot on average. I think we're going to see more days in the upper 80s to lower 90s than mid 90s to upper 90s. But I can't rule it out through at least early August. Any changes to your thought on boundary layer condition and impact for after this past week? Great question. In fact, here, let me see if I can pull up see if I got the observations here on that. I think I forgot to save it, which is bad on my part. There. New Jersey water table. There we go. Okay, so we don't have a map. Well, we can't get the idea based on here. We definitely seen an improvement over northern New Jersey. I should have pulled up the link. I gotta find that. But has there been a change? Yes, for Connecticut, the Hudson River Valley, northern New Jersey, parts of northern New Jersey. But we still have a lot of pockets. I'm not confident of adjusting my ideas based on that, based on what we were talking about last week, until I get a widespread rainfall event. But that's the thing with summer convective events, is that all you need is one storm, because we have light winds aloft, to pop off around here to produce a flash flooding event. That unfortunately doesn't reduce the threat of these dry pockets killing other storms. We need a widespread, moderate rainfall event to really overcome these mesoscale factors. Do you think we're going to see tornadoes in New York City in the next few years? Growing nervous with an increase in severity of storms. Westchester was crazy this week with storms and flooding. No notice from any news outlets or Twitter folks. Okay. A lot of interesting factors here. Go ahead, I pulled up this map. The urban heat island effect, in the I-95 corridor. Let me see if I can get an overlay of major highways. All right, perfect. Okay, so you see this corridor right here? Well, we built up a lot in this corridor, and it's led to a microthermal gradient. That's your urban heat island effect right here. And you can take that all the way up into southwestern Connecticut. Now, what that's done is that it's caused small micro boundaries to the north and west of I-95. And what that does is that it leads to the ability for mesocyclones and microcyclones to develop. Now you get a thunderstorm with enough divergence and diffluence aloft to pick up one of those cyclones, and that's how you see an increase of tornado activity. Combine that with the fact that we're able to observe them better now, so we're able to warn them or at least acknowledge them far more frequently. Yeah, I do expect an increase in tornadic activity. F0s and F1s, nothing like a F3 or F4 or anything you see in the plains. But still, there's definitely that potential. I would say the suburbs of Philadelphia, north central New Jersey, you can throw in Monmouth County every so often, and down towards the coast here, where you get your sea breeze fronts, and you get some influence from Cape May Bay here. So you can put this area right here in southern New Jersey, this area in central New Jersey, and then north and west of I-95, which would include portions of northeast New Jersey and the southern Hudson River Valley and southwestern Connecticut, as areas where I do expect an increase in tornadic activity overall as we move forward. Now, what's interesting is that as we have seen an increase in moisture in the atmosphere and an increase in 500 millibar heights in this environment during the summer, we've actually seen a reduction in severe tornadoes. Every so often we'll get a major outbreak, but we've actually seen a reduction in F3 or higher tornadoes in the plains and in the southeast. It's very interesting. I'm not sure why, but I think it has something to do with the way that the thunderstorms develop, and maybe we're seeing more downdrafts, and so that's interrupting the circulation, but I'm not entirely sure. And they're still doing research on it, so we'll wait and see. People far smarter than me are working on that right now. If you have a natural, let's see here, I want to make sure. Okay, there's a turn. If you have a natural gas connection for the house, look at a backup generator that work on natural gas. Yeah, totally. We're taking a look at pretty much everything, as long as it works. May even do solar on that too. Average high for my part of Union County is 86, 87 this time of year, so average is still hot. 97 is only 10 degrees above average. Yes, that's true. Only 10 degrees, but still it's hot. 10 degrees in the summer is hot. Okay? You do not want to be 10 degrees above normal in the winter is no big deal. It's comfortable. Depressing for some, but comfortable for many. In the summer, 10 degrees above normal is no bueno. No good. I do think we are heading back towards Miller Aid this winter if the PNA can linger for once. I can see it. I can definitely see more Miller A storms. I'd want to see a neutral end snow period for the entire winter, coupled with an MJO that stays around 7, 8, and 1. And I need a sustained west-based negative NAO. You get that, then that's going to force the PNA to lock in, and then you get your Miller A's on parade. Did you see the EPS had 100% probabilities for 100 plus in Middletown, Monmouth, and Union counties for Sunday? Yeah, that doesn't surprise me. Your 850 millibar temperatures are going to be maximized. You have a ridge axis over the region. Let's see here. Pull that up here. So on Sunday, in fact, here, let me pull this up here real fast because I saw something that was really interesting in the 12Z guns here. Here we are. 500 millibars, your zonal pattern, confluent. 700 millibars, same thing. Notice where the ridge axis is. 850 millibars. And look at that for Sunday. So you have substance in place of 500, 700, 850 millibars, a ridge axis, a shortwave ridge axis, not the large wave, not the Bermuda Ridge, but a shortwave ridge axis at 850 millibars. And then you have 850 millibar temperatures over 20 degrees Celsius. When you exceed here, that's trouble. And we get pretty close to around 23 degrees Celsius. So combine all those conditions, wouldn't surprise me one bit we hit 100 degrees. None at all. Okay, let's check out to see what we got in the YouTube chat. Let's see here. All right, let's see. Good. I can hear you. I can hear you. Okay. Good. Well, we know that. All right. So just to get the weekly question, thunderstorms actually are much harder in this type of weather pattern. And I'll show you why. Let me see. Okay. This is a skew T chart. When you get these type of temperatures, the atmosphere is unstable. That's true. But the cap, all right, to get to the convective temperature is much more difficult because you have a lot of substance in the air because of this right here. Okay? So it's more difficult to get thunderstorms in this pattern because it's more difficult to break that cap. With that being said, if you get a thunderstorm to ignite, like let's say on tomorrow with that weak trough that's passing through, they're calling it a cold front, but it's really just a weak trough. Then you can get some pretty impressive thunderstorms, some very, very heavy rainfall. But you're gonna have to have perfect timing, and it's going to be widely scattered, isolated, and many locations will miss out completely. But if you do get one, expect vivid lightning, very heavy downpours, and downburst wind gusts. Are we going into a warmer area in the universe because the Earth has had periods of cooling versus warming since its evolution? Is there any interaction of other planets to assist in this effect? I picked this question because I find it very interesting and very... it's a unique question, Judy. So, I'm going to be very difficult. It is difficult. I'm going to be very thorough in explaining this. The Earth, yes, has been warmer, It's been cooler. It has gone through many different cycles for many different reasons. From the axis between the Earth and the Sun, the influence of meteors, the evolution of our oceans, all sorts of factors. And I don't think this has been very well explained because, well, let's just say that some people aren't the best at explaining scientific literature, but they're really good at creating a lot of hyperbole and a lot of excitement. So, the reason why it's very interesting to see what's been evolving here is not the fact that we're getting warmer. It's the rate in which we are increasing CO2 and methane, for that matter, and the rate in which our temperatures are warming, which is still slightly below what was projected by the model guidance, but still going up, is a problem. And the reason why it's a problem is not because it's a question of whether it's warmer or cooler back from the time of the dinosaurs or anything of that nature, but because of the rate that you're changing things, you can't adapt. See, evolution takes time. Adaptation takes time. Humans are very good at adapting. But if you have rapid adaptation, if you have rapid change, that little niche that allowed us to take over the world, so to speak, becomes limited because you don't have enough time to adapt to these changes. And we're very good at that. Imagine plants. Everyone mentions, well, more CO2, then you get more plants and you get more growth. Yes, but that's over thousands of years to adapt, not 100 years. So therein lies the problem, is the rate of change. Now, look, at the same time, we also have to recognize that if we didn't have that technology, we wouldn't have all the advancements we have. We wouldn't be here. So we have to acknowledge that. So let's, it's easy to just blame the oil company, but then you'd have to blame yourself too, because you were driving, weren't you? You're flying, you heat your home. So it's kind of being a bit of a hypocrite. So what do we do now? That's the question. Everyone wants to blame things and blame this person, blame that person. Blaming is for 5-year-olds. How do you solve this? Well, you can't go around telling people in undeveloped countries, in the Asia and Africa, South America, hey, you can't have coal and oil because we did and it ruined the earth. That's kind of hypocritical too. So you have to have an energy source to compensate for what you're going to take away from oil and gas, i.e. nuclear. And yeah, solar and wind, you could use that too, but nowhere near is going to meet the capacity. So you have to do that. You have to make that adjustment while at the same time keeping the same quality of life. Because people vote, and no one's going to vote for a political party that's going to cause you not to have your car, not to have your creature comforts. That's just how humans are. So, if you really want to solve the problem and acknowledge human nature and acknowledge our limitations and acknowledge the fact that people respond to whether or not they can feed their families, not a political cause, then the logical choice is to invest in an energy source, which I believe it would be nuclear, that can replace oil and replace natural gas without destroying the standard of living that most developed countries have and that undeveloped countries or developing countries can get to. And by doing that, then you reduce CO2 You increase carbon capture, which is a technology. And you increase the ability to transfer out of oil and coal and natural gas in a way which is realistic. That's how I would do it. The reason why is that if you reduce the rate in which you're putting CO2 in the atmosphere, then the Earth will naturally readjust, and then you're able to see how the Earth balances everything out, and then we'll be fine. That's what I would do. That's my opinion on the matter. And then you fall back into your natural cycles, as you mentioned, Judy, depending on the evolution of the sun, whether or not we go into a grand solar minimum, our magnetic fields, and also volcanic activity, among other things. So that is the answer that I think you deserve, that I would want you as followers to take from that. And go back to the map, and we'll drop back to our premium chat and see. Let's see. Do you expect both days this weekend in Union County area to hit or go over 100 degrees? Saturday's going to be close. I'd be thinking more like 98 to 100. Sunday would be the day where you could go 100 to 103. I assume we would have widespread rainfall, but what effect would the dry boundary layer have on tropical systems? Because of the widespread nature of the tropical moisture, it would override the mesoscale and microscale influences that we've been dealing with. The reason why we've been having problems with convective systems is that thunderstorms don't have the support that a tropical system would to overcome that influence. Let's see. Lifespans were far shorter before the Industrial Revolution. Absolutely. In fact, before the Industrial Revolution, I would be an old man. Because you got to your 40s. Congratulations. If you got to your 60s, you were considered a wizard. And then you get a big hat. So that's kind of cool as a retirement gift. Yeah, I mean, absolutely. Lifespans were a lot shorter. Still need to find substitutes for all byproducts of petroleum refinery that go into every modern day product. Absolutely, Card. You're absolutely right. I'm not denying that at all. You're absolutely correct. That would definitely be a heck of a challenge. There are some experiments and some investment in finding that. I don't have an answer. That's beyond my scope of understanding. Let's see. And it's about 8:50, so I'll take a couple more questions, and then we're going to call it a night. Let's see. We're doing pretty good here, too. Definitely a nice active live chat. Again, I want to thank everyone for definitely dropping in and visiting, especially during the summer. I know in the winter it's going to be absolutely crazy, and I do have some plans to have some improvements with the chat as well. But I want to thank you all for definitely joining and asking these amazing questions, even if you do want to know whether or not we're going to have thunderstorms. Because yes, we will, just perhaps not in your backyard. But I can say that it's been a lot of fun answering your questions and kind of going over everything. So I think that's it for the questions for tonight. So I think we'll wrap it up for tonight. Thank you, as always, for being here. And we'll see you next week. And maybe we'll have a little bit more to talk about besides climate and whatnot. Maybe a thunderstorm outbreak or something of that nature. Have a wonderful night, and as always, stay safe out there.